Hello, physics fans. So here I am, and I'm going to reiterate some of the instructions for our centripetal force lab in case you have questions and or need some further clarification after we go over it in class. Now, I'd like to first talk about the general contraption and how we use it to measure centripetal force. Since we're talking about centripetal force, something's going to move in a circle. I have a picture that's also on your lab handout, and I want to build this sort of contraption first. You have some fishing line, and it's a 50-pound test. And I'm going to do about an arm's length and a half, all right? And then I'm going to cut it. And after I cut this, we're going to want to put a loop on one end. And when I make my loop, you may need some assistance in the future, but I make a loop, and then I make a second loop with this loop, and the end of the first loop goes into the second loop, and I have something that looks beautiful like so. Now the reason I need that is going to hook onto my mast that's going to hang down through the center. Once I've done this, I can then take the end and put it through my tube. This might also present logistical challenges, but you should be able to get it through. Beautiful. Now, on the other side of this, we're going to tie a stopper. And so we tie our beautiful stopper to this. I may not be in the shot, thank you. And so on this one, I'm going to tie a stopper. And then I'm going to show you the general motion of how this thing operates. Now once you've tied your stopper on, the first thing I want you to do is give it a good tug. Make sure your knot's going to hold, because the last thing we want is for the stopper to come flying off. Now, I have a general contraption of which I can hang a mast from here, and I can swing the stopper overhead. Now, you can see I'm doing a very nice job, and this is exactly the model of how this is going to operate. However, what we want is to have a constant radius, which is the string that's spinning the stopper. And so we need to mark that constant radius as a meter. So you take your meter stick, and we want to measure this thing out to be exactly 1 meter. And so I have 1 meter from the stopper to my handheld. And then what I'm going to do is I'm going to take a piece of masking tape, and I'm going to place the masking tape a little below my handheld, so that now when I spin this guy, I'll know exactly that there is 1 meter hanging down. I can get all this together, and then I start swinging this guy, and now watch what I've got here. Ah, beautiful. Now you can see what my masking tape is just below. Oh, I went a little too fast and it went up. And we kind of have to have a Goldilocks spinning approach. And what I mean by that is I need to have a situation where I'm spinning just fast enough that the tape stays just below. If I go too fast, the tape will move up. And if I go too slow, the tape will move down. And so I'm going to spin this. And then your partner is going to time how long it takes to go 10 times around. And if we know how long it takes to go 10 times around, we can establish the velocity of the stopper. Now, we're going to use this same contraption over and over again. And we're going to do so by changing different parameters to measure the variables that affect centripetal